Hello, everyone. My name is Matt Makai. I'm a Developer Evangelist at Twilio, which pretty much means I work on open source projects and travel and speak at tech conferences, that sort of thing. I'm based out of the Bay Area. And I also write a site called Full Stack Python, which is read by about 100,000 developers every month, so that they can build, deploy, and operate their Python applications. And I've been working on that for about 5 years. It's an open source project on GitHub. In case you're ever interested in not only building Python applications, but also Python DevOps tools like Ansible, things like that. I have a lot of tutorials on that. Now, assuming my clicker actually works here, so I primarily program in Python and in Swift. So I don't have a ton of more recent Java experience. So this talk is going to be a little bit higher level on the DevOps side. I do about 15% of my time, 15 to 25% of my time in Java, but I mostly work in like micro frameworks like Spark as opposed to really heavy frameworks like I used to, like Struts and Gwt. So I spend most of my time building Python applications, but also building and then releasing mobile applications. And the reason why I bring this up is because the way that you do that in those two ecosystems is completely different. So even from waking up in the morning and being like, oh, I got to write some Python code, like I'm firing up Vim on Linux versus writing some Swift code either in a playground, an Xcode, or actually just firing up the Xcode editor itself. And then, of course, the release process for a mobile application is very different from deploying a web application. So part of this is the way even that I do, like sort of the DevOps, the deploying and the operation, even just in these two ecosystems is very different. And while I would say that in the Java ecosystem, it's probably mostly like Python, and we can draw the parallels between all of the concepts, you're still going to have a lot of differences in sort of the way that you're operating your projects at scale. Now, I bring up Java partially because I used to just do Java development. So this was like fairly old school EJBs back in the day. This was like my first job out of school. I was doing just pure Java development, and I've been doing Java through high school and then in college. And so I got my first Java gig professionally, and this to me was my dark ages. And this was in 2004. So I say to me that it was like the dark ages, and for some people they're going to be like, that's really offensive. Like the dark ages were like the 80s, or they were the 60s, or something like that. Or some millennials are going to be like, dude, you're really old. Like you've been programming for a long time. This is my personal dark ages, where I basically knew nothing. Like I was coming out of computer science, and I was like, what is even out there? And I discovered the first tool that I think kind of brings some people along on this DevOps journey, their own personal journey of whether they really care about just kind of building the application or whether they care about the entire life cycle of the application. Not that one is necessarily better than another, but just do you really care about building the features and constantly building and releasing new features, or do you care about kind of like the deployment, the operation side, as well as building the features? And then you kind of specialize in your own career as to how you want to do that. So the tool that I discovered, which many of us kind of just take for granted now, but I thought was mind-blowing at the time, was source control, also known as version control. And of course, we didn't have like amazing, gorgeous web application user interfaces back then. I was working with IBM's Rational ClearCase, which still kind of, I don't know, I have bad feelings about that one. But now we get tools like Git, which are like spectacular, along with the diff views that they give us, and just kind of the way that we can develop our applications and not have to always sync with a centralized repository. We can actually just go off and do our own development and merge later. So source control is kind of like that foundational technology, which I think often gets taken for granted. Like 10 years ago, source control actually wasn't all that common because a lot of the open source and free versions were not that good. I mean, you had sort of SVN, CVS, but we've gotten a lot better. So what I always like to say is like, pat yourself on the back if you are using source control, because it actually is like this foundational technology that kind of like allows you to do all of the automation on top of it. And people often forget this. Like I often talk to many college students, and like, yeah, sure, they like kind of understand like what Git is, but they're not really thinking about it as like the building block on which you build other things on top of it. So if you don't have your source code in version control, like how are you going to use continuous integration and either compile your application if you're using a compiled language, or run your automated tests, or test that your application dependencies are actually installing properly and that you've pegged to the correct versions? How are you going to then figure out how to automate your deployment and manage the state of your servers? Like all of these things kind of build on top of just having some sort of source control repository to work from. And then of course we would talk about something like monitoring, logging, measuring. So that is sort of the foundational layer for doing everything else that oftentimes gets lost among all the tools that we talk about at conferences that are all nice tools to use, but there's also that foundational layer that we need to know about. So I've got 10 questions here, and these 10 questions, the first one of them is, do you know a developer who strongly recommends a tool after insert generic number of years here, but after a significant period of time that they really can tell you, you can say like, do you recommend this tool? And then they like tell you about how great it is. And then you're like, no, like tell me what's really bad about it. And then they tell you all these like, oh, it doesn't do all these things, but they still really love using this tool. And so what I've done here is I've created these 10 questions that are kind of a little bit introspective into our own environments for how do we, going back to the title, how do we adopt tools in our own organization for our own personal use or in organizations? And so if you know a developer who's been using something for a long time, and I'll give one example here, and I'll give a few others, but for me, that's Git. Like I've used all the version control systems, or a lot of the version control systems out there. I love using Git. Awesome. That provides like that foundational layer for me. If there's something better in the future, cool. I will totally use that. But for me, as far as a version control implementation, like this is fantastic. So a lot of times what gets lost, especially at conferences when I'm talking to people, people come and they're like, hey, I really want to learn about X tool, right? But this is also like a step in, I think, a lot of people's evolution, where you have to ask yourself, do you know what the difference is between a concept and an implementation? So this is a shift that has happened over the past maybe 10, 15 years that I think a lot of developers don't talk about, which is there are companies, large companies, that hype up and get really excited. And I work for like, I'm subjective, but I objectively really enjoy using the Twilio API. But there are large companies that are billion-plus-dollar companies that hype up their own tools. And people will go to conferences and they'll talk about like, hey, I want to really use Docker, right? Like, oh man, Docker is amazing. I want to learn about Docker. Without at all understanding, like there is a conceptual idea that Docker is implementing. Docker is one of many philosophies behind implementing a conceptual idea which is known as containers. And this happens to be the logo for LXC, which is containers on top of Linux. But like, if you don't separate the hype for a tool, like Docker's like got $1 billion valuation and all that stuff. They've got great marketing people. They've got a lot of great developers as well. And I go to their meetups. But like, if you don't separate the fact that like Docker is just one tool, one philosophy and implementation of how you use container service, like then you're never gonna be able to understand how to appropriately fit in a conceptual idea into your own team and your own environment. You have to understand the concept before you worry about what tools you're going to be adopting. So as you go to other talks throughout the next couple days, think about like, okay, yeah, sure, they're talking about like Spring MVC, that's pretty cool, or Spring Boot, something like that. What is it really implementing? And the reason why I think this is like just really important is like this forms a lot of the foundation for when I write full stack Python. There are many tools in the Python ecosystem that are out there. So to just take a look at this, under web development, people will often just like, especially coming out of coding boot camps, they'll be like, oh, I use Django. And you're like, cool, like why do you use Django? And they're like, well, I just heard it was kind of like the best tool. But like Django is one implementation of the web frameworks concept. And we can translate this into the Java world as well. Like I really like using Spark because it reminds me of Flask and it's a nice micro framework for building really simple Java web applications. And Gwt is really good as well. And you can kind of like go through the laundry list of all these different tools. But if you don't understand what a web framework is and the fundamental foundation behind web development, like you're kind of just getting lost among the hype among the tools. You're not really like picking out the right, maybe you're not picking out the right tools for your own job. You're just going along with what other people are saying is like the best thing to use. And that's like, I think someone else coined the phrase hype-driven development. That's where a lot of software comes now. Like it's not thinking about like the ideas and how you put them together. It's just like, well, what company is like really excited about a certain tool that they are promoting? So let's go to the next question about sort of adopting tools in your own environment. So how many people, like just kind of knowing, and this is like a little bit more geared towards like tech leads, senior developers, but like how many people get really stoked about making incremental fixes to your technical environment? So there's like sort of, you can kind of tell a little bit about the state of your team based off of people that are like, you're working with a bunch of tools and you've got sort of things that you're working on and you're making small improvements every single day. Versus like, and so you can kind of, let's say you have 10 people on the team, 10 developers, and like 8 people are like really excited about all the change that you've made. Like every week we're making progress, every sprint we're making like some fixes. And then you've got like a couple people that are like, we gotta like just throw everything out and rewrite it. And some people are just more geared towards one or the other. But if everyone on your team is like, we need to just throw everything out and start over, like that's gonna tell you a little bit about whether, like how, like what you're like doing on your, like how your team is doing overall. Like probably the best situation is everyone is excited about making small incremental improvements to your environment, and then you celebrate those small wins. Another question is, and this is like kind of aligned with it, ask yourself, like, are you working with software people or process people? Now, this often comes in very large organizations. Like I've worked for like some very large financial institutions. And the answer to like every problem that came up, like if we had a failed build, failed deployment, we had to hotfix something, we had to, we had a bug in production, was like, whoa, 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 there's too much change. We need a change control board. Like we need to like understand the change. Like manual controls. Those are not software people. You have to kind of understand in your own organization how many software people there are versus how many manual process people there are. And it's gonna vary by industry, but the software people are gonna be like, something got messed up. Can we write a unit test to make sure that we can check and make sure it doesn't happen again? Can we put monitoring in place? Can we put a software automated solution in place to make sure that this doesn't happen? And this is gonna heavily impact your ability to adopt any sort of tools when you're building, deploying, and operating web applications. Because if you're dealing with a whole bunch of process people, you're gonna spend, and this sucks, as a developer, a lot of political capital, which we don't really talk about, but like you have to have the political capital in order to adopt those tools in your organization. And my personal recommendation is developers, especially with the economy being very good, if you get frustrated in those environments, like I got frustrated in those environments, you should probably leave. You should probably just go find, because there are so many companies that are filled with software people and that don't put all the roadblocks and the processes in place. And chances are when I like give this talk, what I like to do is when I give a talk, I like to have about half the people in the room be like really pissed off with what I just said, and hopefully they can kind of think about it and be like, no, you're wrong because of all these reasons. But by and large, like this is just stuff that I've seen over time as a developer. And so like the reason why I bring it up is because this is a lot of like what we don't really talk about. We don't really talk about political capital. We don't talk about software people and process people and why that's really bad. Like I just like to bring it up, and if you're like really uncomfortable right now, that's a great thing. I'm sorry that I made you uncomfortable, but like you should really think about why your organization is the way that it is, because it really does impact your ability to deliver quality software. So we went back to source control. Let's talk a little bit more about what we build on top of source control that allows us to deliver quality software. A lot of this comes around like you've got your source control in some sort of way that you can interact with it programmatically. So let's say Git, for example, as the tool and the conceptual ideas like source control. And so now you put these other conceptual ideas in place, like continuous integration, automated testing, and handling of your application dependencies to make sure that like things are not breaking over time. So these are some implementations. There are many hosted solutions out there. I personally am not really a huge fan of hosted continuous integration, but maybe it's just because that's not like something that I've really worked with a ton in the Python ecosystem. Some people like swear by some of the tools that are out there. I certainly have used Travis for open source projects because it happens to be free. AWS, I have not used their particular tool, but if you're on AWS completely as a platform, maybe that's the right way to go. I personally use Jenkins a lot, and I think that the Go CD continuous build deployment pipelines are an interesting concept. I just haven't seen like a really good practical use for them. But these are like the tools that you'd potentially put in place that are going to allow you to then check the quality of your software. But if you're not really like, beyond compiling, like you're really going to be doing a lot of testing. And this is often where like people are like, yeah, I do continuous integration, but I don't have like a ton of tests going on. But this can really happen like in any environment. Like I was working in a military intelligence project. We had tons of tests everywhere. Like this is not like you can only have tests, like automated testing in like, an internet company. Like any environment can benefit from testing and can absolutely do testing. In the Python ecosystem, the implementations that we use are like unit test, PyTest. We use Nose as a test runner. So you kind of have like what is actually running your tests versus like mocking things out versus code coverage. These are kind of the important concepts in that space. So I was on a project where we had fantastic continuous integration, really great test coverage, great reports for that. And then they said, hey, like we want to automate our deployments. And this is like way before like Puppet or Chef or anything like that. So I ended up writing, and it worked. It wasn't great, it was very brittle, but I wrote a lot of like bash scripts to do that, right? And bash scripts, like, they can get the job done. Like they can totally get your code out of like that source control repository and into your test or production environment, and that's totally cool. But there's a lot better tooling now to do this. And the first one that I kind of came across, which was really a wrapper, it's really a wrapper around SSH, and this is in the Python ecosystem. But I will say that this is totally applicable to any Java application that you're also writing. Like the DevOps tools, by and large, tend to be either written in Ruby or Python anyway, so you don't really necessarily have to learn those languages, but most people tend to at least get a little bit comfortable with them so that they can actually do the deployments in their and for whatever ecosystem that they're working in. So I really enjoyed using Fabric. Fabric is really just a wrapper around SSH that allows you to execute shell commands, but you can execute shell commands as Python functions. So arbitrary Python functions, arbitrary shell execution in Python functions. But again, still kind of brittle, not that much different from Bash. And that's why really now I've adopted using Ansible. Ansible is an open source project written in Python that I've been using now for about almost 4 years. So I guess I would say that I strongly recommend it, even though it certainly does have some warts. So these are just some of the implementations that I personally use in my own projects, especially on the web development side. So let's say and a lot of people are probably in the situation where they've already, okay, fine, all that stuff. We've got CI, we've got our testing, we've got all that stuff, right? So, and that, once you start to get into Ansible, then you're getting into the configuration management space, which is a little bit more the managing the state of the servers and the deployment pipelines themselves. And there's a bunch of tools out there. These are open source. Again, the tooling itself, you have to make sure that you're choosing the right thing for you, but these are all implementations of the configuration management concept. And roughly what you're doing here is, like instead of writing a bash script that would say like apt-get install python dev or supervisor or whatever system packages you need, you're going to use some sort of intermediate language, maybe not necessarily a programming language, maybe a DSL, like a domain-specific language in the case of like Chef. But the reason why I particularly like Ansible is you're really just writing YAML, yet another markup language. I wasn't really a huge fan of YAML when I first started writing it, but it's really grown on me. And the idea here is you're converting from just the pure shell command into something that is repeatable not only on Ubuntu, but also potentially on other systems. Now, some of that stuff does depend on which, like this won't necessarily run on Windows, but it does give you a little bit further of an abstraction as opposed to just running a straight Ubuntu command with apt or aptitude. So that's kind of the idea behind the configuration management tools. I do think that like asking yourself how many times a day do you deploy to production, how many times a day do you want to deploy to production, let's kind of like think about where like sort of separate like your own organization from like where you actually want to be. I have seen a lot of environments where a lot of technical environments where it's not really possible to move from deploying quarterly to deploying a dozen times a day. Like it's not possible. And the reason is because you've got a whole lot of process people. You've got too many process people that outweigh the software people. And so if like you really care about deploying a lot, and that's something that you want change to happen fast, at least internally, if not the interfaces to your external customers, but you want like change to happen rapidly, like then really you should really be thinking more about potentially being in an organization that has a lot more software people. We are very fortunate, this is kind of like a plug for what we do, but like we're very fortunate that like every year in our conference, like our CEO gets up on stage and talks about the number of deployments we did to production the year before. And these are not things, so we did 6,643 in 2015. It's much more in 2016. I actually don't know the number off the top of my head. But one caveat to this is these are not changes that force external customers to like implement a new interface or something like that. A lot of this is performance improvements. A lot of this is like new features that you can adopt. And some of them are just like, hey, whatever we had as default before, like you can now flip a flag and you get something new, right? But it's, I don't know, maybe this is a defeatist attitude. I really don't think you can go from like deploying quarterly, like in the environments that I've been in, to doing this. Like I just don't think you can get there in any sort of reasonable career amount of time. Like I think you just kind of have to leave your company. And I don't know, maybe that's a defeatist attitude, but that's just kind of how I feel. So, but this stuff is totally possible, and anyone who tells you that like, no, you can't deploy dozens of times a day, or like, that's the sign of bad software, like, has obviously not been in an environment where that is actually the case. I do think that like there are certain people that get really excited about continuous delivery and working on projects where they're actually helping to, do the deployment, improve the deployment pipeline, those sorts of things. So thinking about who the people on your team, who are in your organization actually gets excited about this stuff, like those are probably the people that should be working on it. I do think that in some ways there are application people who get really excited. I think maybe even Randall's like this. Randall gets really excited about like shipping software, or shipping, and when I say shipping software, I mean like building application features. He's like, dude, just like give me Heroku. I just want a platform as a service. I just want the stupid thing to work, right? But I actually really like working on the deployment pipelines themselves. So for me, like I'm probably the person that should be working on some of the deployment pipeline stuff on a team. And Randall should be shipping the application features. A lot of teams just sort of, especially in the days of like, now in the days of like everyone being a full stack developer, like, oh, everyone works on everything. But like, really, is that really the most productive way to like apportion people's time? Like certain people get really excited about this. And if you're in the audience and you're like, I don't really care, I'll just use like a platform as a service, like you're probably not the person who should be working on this stuff. Like there are people who like totally geek out about this stuff. Like I ran a meetup group called DC Continuous Delivery where all we did was talk about this stuff, like cultural change and tooling and ideas and stuff like that. I got really excited to go every single month. And some people just don't care. They're like, I have no interest in going to that meetup group. So knowing who actually does care and who doesn't, that's probably going to determine who should be working on various features in your team. Now, part of it is like some people look at this map and they're like, this is amazing. This is a map of like a lot of the stuff you can do with a web application deployment, particularly in the Python ecosystem. I got really excited. I drew this. I could tell the people who got really excited about this were like, they're the people that should be working on like continuous delivery stuff. And some people are like, this is really annoying. I don't care. I just want to ship some software. Like I just want my stuff to work in production. So that's a good litmus test. If you show this to somebody, if you show this screenshot to someone and they're like, this is really cool, I want to learn more, they're probably sort of like a continuous delivery type of person. I do think that just kind of knowing the top specific impediment to completely automating your deployments and always knowing what that is and working towards fixing that is really important. So just always having that top of mind, especially if you are like a tech lead and you're trying to figure out like what are the incremental improvements we can make as a team. What are those impediments, or what is that top impediment, and always kind of knocking out that top impediment. Some people, I don't know, are like really big like planner people. I am really not. I go one sprint at a time, and I always like to know what the top problem is. Let's knock that top problem out. If that top problem is not solved in a few sprints, well, we need to break this problem down into some smaller increments so that we can actually solve something and feel like we're making some progress. So on top of sort of the configuration management deployments, which is where like a lot of people just like assume like DevOps is like configuration management tools, which is kind of weird, or like just the deployment pipeline. But really like operating it is it's like the second half of DevOps. So like the operation stuff, like for a lot of continuous delivery people, also still really gets them excited. I was working on a consulting project. They brought me in. They were like, hey, we need to like ship some new app features and stuff, right? And I was like, okay, cool. I started working on it. And then I took a look at their production environment. They were running a monitoring tool called New Relic. And I discovered they, like every single page that had anything to do with Unicode that they were pulling out of the database was just like not working. Like it was like 500 erroring. At least it was giving like a reasonable sort of like error page. But they had a very large international audience. And they had no idea that like none of their international audience could read any of their pages because most of those pages had Unicode. Like they just had no clue. And it wasn't appearing in Google Analytics because Google Analytics snippet was on their error page. So they didn't see any problems with the traffic. They really like just had no idea that they were getting thousands and thousands of errors every single week, and their entire international audience base could not like basically read their website. And that's why I think that like if you are a developer, like just knowing what these monitoring tools are and like knowing the percentage, if you can, I don't know, it's kind of an interesting way to look at it. Like what are the percentage of errors that you know about before your users, right? Because like if the users are the ones who are reporting the errors, like you've kind of done a bad job. Every time I see somebody report an error with Twilio, like I get frustrated because like we should know about that before they do, and you should always try to be proactive about that. Because otherwise, like the people downstream are the ones that are getting frustrated, and who knows? You have no idea how long those errors have been occurring, or if you don't know how long those errors have been occurring, that's like a huge problem. So on the monitoring side, I often use Sentry. The reason why I bring up a specific tool is just because Sentry also happens to be open source. And I do think that when you look at sort of like the business models of various monitoring tools, like monitoring tools will basically like suck out all this instrumented data out of your applications and will store it, right? And it's kind of hard to get them out of the tools. So if they go up market, like certain companies, like, I don't know, like AppDynamics just got bought by Cisco. Do you think their prices are going to go down? No, they're not. They're going to go up a lot. If you've got all of your data in their service and there's no open source version of that monitoring tool, what are you going to do? Like you kind of have to pull it out and try to shove it in a different tool, which is like an engineering nightmare. So the reason why I actually think using some open source tools, even if you're using, like I use the hosted version of Sentry, but I know that if like that project just doesn't take off and I don't want to put any budget towards it, like then I can just set up my own server with Sentry and then, okay, then I have another place to store my data that is exactly the same as the hosted version. Also, Sentry works really well with Python projects, but it works across all different ecosystems. So that's one reason why I really enjoy using that particular tool. And also, as you're collecting like your errors, you're monitoring your environment, like which ones are feeding back into every single sprint? Like a lot of times sprints are just only about new features. But if you're not actually looking at like how do we decrease the number of errors that we have in production, how do we decrease maybe the 404s that users are getting because they're not actually done by just crawling bots or something like that, if you need to like find some way to feed these metrics into every sprint. And this is actually how I've found that like most teams are able to kind of complete that DevOps loop. Because like if developers are always just building new features, like that's okay, that's fine, but you haven't really changed your process for how you're actually building software. And so I think just asking yourself like what metrics are we using from production to actually feed back into our sprint development cycles, like that, I don't know, just asking that question of yourself and your team, like what are, just calling them out, I think can help try to figure out like, okay, how are we closing this loop from production to actually our development cycles. This is a random one that like when I was like a 22-year-old developer or a 16-year-old developer, I would have said zero money. I will build it all myself. But as you start to build more complicated projects, sometimes asking yourself like, what can I spend money on, and just use a hosted service can actually be really helpful. Like, and it's not the case of like you have to go and spend like $1,000 a month on some monitoring solution. Like, you can spend like 20 bucks a month and get some fantastic monitoring and just take that off of your plate. A lot of it just depends on your team. Like, you may not care. If you've got 50 developers on your team, you've got an entire slew of developers that are focused on monitoring tools or something like that, you're already kind of spending money. You're spending their time and resources on it. But as like if you're doing a lot of like your own development projects, you're running your own applications, I found this to be more and more valuable as I've allowed myself as a developer to ask myself where to spend money. So that was kind of a random walk down some of the different conceptual ideas and trying to ask some questions that like probably a lot of people find uncomfortable and are a little bit high level, but just kind of going through, source control is sort of that foundational layer. You have some programmatic access to your code as, like your code essentially becomes data at that point. You're executing your code because you can pull it out of source control programmatically. Then you are testing it in an automated way with CI, testing your application dependencies, making sure there's not negative interactions, and then we talked a little bit about some of the conceptual ideas behind configuration management tools, some of what those tools are, and using them to do server state management and deployments. And then we talked a little bit about monitoring, logging, and measuring on your applications, and some of the pressures and why I strongly believe in using open source tools that I can switch over to in case their company decides to go up market and I do not have the money to spend and I do not feel like getting my data out of their service. So anyway, that's a random walk about adopting some DevOps tools for you and your team. My name is Matt Makai. I'm a developer evangelist with Twilio. I'm also the creator of fullstackpython.com. So if you're interested in these topics in more depth, particularly in the Python ecosystem, that's actually where I write the details of the tutorials, those sorts of things. If you like this talk or if you hated it, you can also email me, makai@twilio.com, and I'm Matt Makai on GitHub. Thank you all very much. If you have questions and stuff, we might as well just we'll just go outside the room and take questions. Also, I think lunch is served, so get out early for lunch.